Welcome to the Unit 2 test review on deductive reasoning. Let's get started. Okay, given the conditional statement, if I go to the store, then I buy groceries, I want to state the conclusion and I want to state the hypothesis. First of all, when I'm looking at this if-then statement, everything after the if is my subject of my sentence and it is my hypothesis. Everything after the then is my predicate of my sentence and it is my conclusion. The if and the then are not part of the predicate. They are not part of the conclusion. The if and the then are not part of the hypothesis and not part of the subject. So now when it says to state my conclusion, it's everything after my then. It's my what's going to happen. I buy groceries. I want to state my hypothesis. It's the if part of my statement. I go to the store. Okay, number 2. With talking about all the different statements, we are now going to, sorry, get this straight. We're going to rewrite this sentence into a conditional statement, which is our if and then form. And then we're going to find the converse, the inverse, the contrapositive, and the biconditional. So first of all, when we're talking about a conditional statement or an if-then form, that is my P, then Q form of it, where P, again, is my hypothesis or my subject, and the Q is now my conclusion or my predicate. So first, looking at this statement here, our vertical angles are congruent. All vertical angles are my subject. Our congruent is my predicate of that sentence, which means that my if is going to have to involve this, and my then is going to have to involve this. So if I rewrite this statement, I can rewrite it along the lines, if the angle is vertical, then it is congruent. With this statement, my hypothesis or my subject needs to be a complete sentence. We've talked about that several times in class. It needs to be a complete sentence so you can draw a conclusion from it. Now I'm going to do the converse of this if-then statement. If you recall, the symbolic notation for converse is Q, then P. So if my symbolic notation for my converse is Q, then P, it means I'm going to take my conclusion, it's going to become my subject. I'm going to take my hypothesis, it's going to become my conclusion. So I'm just going to switch the two. So if the angle is congruent, then it is vertical. Now we're going to look at the inverse. If you recall, the symbolic notation for the inverse of my conditional statement says not P, then not Q. With that, again, this is a similarity symbol. It's not an N. It's not a squiggly. It's a similarity symbol. So if I'm going to say not P, that means I'm negating this right here. So if I'm negating this, if the angle is not vertical, and I'm going to negate the conclusion, then it is not congruent. And I just wrote that into the wrong place. That's my inverse right there. Sorry, wrote it in the wrong spot. That's okay. That's my inverse right there. Okay, my contrapositive. My contrapositive statement tells me that if I have not Q, then not P. I'm going to write it right here in blue. So I'm going to take my statement that is Q then P, and I'm going to knot it. So if the angle is not congruent, then it is not vertical. And lastly, I have my biconditional statement. With my biconditional statement, that gets rid of the if and then all completely, and I'm left with just an if and only if statement in the middle of it. So with the biconditional statement, it says P, so the order is the same. That's my hypothesis. Biconditional is the line, not the arrow, and then my Q. And when I write my biconditional statement, there is no if and there is no then. It just takes my subject, all angles are vertical, puts the if and only if in the middle. Oop, I forgot the only, sorry. If and only if they are congruent. So with my biconditional, I shove an if and only if in the middle. I get rid of my if and my then. Okay, question number 3. Very large. Which is the following in the inverse of not P, then Q? All right, so let's first go with what is the inverse of this statement? All right, so first of all, if we know we have a plain old conditional statement, it is P then Q with a plain conditional statement. We know with our plain conditional statement, the inverse is not P, then not Q. It negates each piece. So if this is my new statement, not P, then Q, I'm going to negate each piece to make the inverse of this statement. So the inverse of this statement says not P is P, then not Q. So that follows down here to P, then not Q. Well, wait a minute. I got two things going on here. Which one is it? This is my inverse form. This, if we recall, is the biconditional form. That's not what we want, or if and only if statement. That's not what we want. So the answer then is A. Watch the notation to make sure you're saying exactly what you mean. Now we're going to talk about one of our laws of deductive reasoning. First is the law of detachment. When I have the law of detachment, I'm going to make a conclusion of the given statement. So I'm given some kind of scenario, some kind of true statement, and I need to make a true or valid conclusion. So it says, if a figure is regular, then all sides are equal. If the figure has 4 sides. So what are we going to conclude from that? It has 4 equal sides. Then we know what? The figure is regular. It doesn't ask, hey, is it a square? Hey, is it a rhombus? That's not what it's asking. It's saying, if the figure is regular, then all my sides are equal. Now I've got 4 equal sides, so what can I conclude based on the given information? That my figure is regular. We're not drawing extra conclusions. We're not putting extra information in. So how is that different from our next law, which is our law of syllogism? The law of syllogism, if you recall, is just like the transitive property. It actually follows a pattern. And if you recall, the pattern says, all right, I have P, then I have Q, and I have Q, then I have R, so then P and R go together. We can make it an if-then statement. That's in the traditional transitive property form. What that means is I have a statement, an if-then statement. This then becomes the if of my second statement to draw a different conclusion. Then the first and last conclusion are drawn together. Kind of like, remember we said friends. I'm friends with Mary. Mary's friends with Bob. So Bob and I become friends. So looking here, let's see if we follow a pattern. If BD divides angle ABC in half, then it is an angle bisector. Okay, so I have a P and I have a Q. I have a conclusion. So now, if ray BD is an angle bisector, okay, that matches this, so there is my Q. Oops, then part of my statement's gone, sorry. Then angle ABD, is congruent to angle DBC. So what can I then draw with my law of syllogism? And sorry, that will be my R. Sorry, I was missing things that threw me off. So now my final statement should be P, then R. The piece that overlaps with the then and the if go away. So now, if BD divides angle ABC in half, then angle ABD is congruent to angle DBC. It has to be an if-then statement. You're not just drawing a valid conclusion, you're actually pulling it together using the transitive type property. So it's not just a valid conclusion, it is actually pulling it together. Oops, sorry. All right, properties. You know we had a whole little section on properties and what properties were what. So what property is being illustrated here? So if angle B is congruent to angle C, then angle C is congruent to angle B. So what property takes it off, flips it to the other side, and puts it back on? No order has been changed. All that's been changed is what's on each side. Correct, the symmetric property. Yes, I write the word property. All right, my next property. AB is congruent to AB. What property is like a mirror and I'm looking at exactly what I see? Correct, the reflexive property. And it says use the transitive property of congruence to complete the statement. So this is like our friends again. If B is congruent to C and C is congruent to D, then angle B is congruent to angle D. Then it draws the two together to become friends. Okay, number 7. So looking at this diagram, what can I conclude? Or what can I not assume? Quite a few things I cannot assume. One, I cannot assume I've got right angles anywhere. If I don't see the right angle symbol, I cannot assume there's a right angle. So I cannot assume that angle 3 is a right angle. I cannot assume angle 1 and angle 2 are complementary because that means there'd have to be a right angle there. I also cannot assume, let's just further our picture here a little bit, and let's draw in some points. So I also cannot assume that angle 1 is congruent to angle 2. Well, sorry, before I get to the points. Because there's nothing here that says it bisects. It looks pretty close, but who knows? I don't know. I also can conclude that BE, the ray, is an angle bisector. They look kind of close, but remember, it's not what things look like. It's what's factual about it. I also cannot conclude that AB is congruent to BC. They look equidistant, but I don't know, so I can't assume it. Remember, you can't assume anything that's not given in a picture. I can't just say, poof. What I could assume is this is a straight line, so I know how many degrees. That's not an assumption. It is a straight line. It is 180 degrees. So just because it's in a picture, there are things you do know, but there's things you cannot assume just by the way they look. Okay, looking here at this picture. So first of all, I want to name a couple things just vocabulary-wise. So first, I want to name a pair of adjacent angles. First of all, adjacent angles are angles that sit next to each other. They share a common side and they have a common vertex. So here, angle 1 and angle 2 are adjacent. Angle 2 and angle 3 are adjacent. They share the common side, they share a common vertex. Angle 3 and angle 5, they're adjacent. Angle 5 and angle 4, they're adjacent. Angle 4 and angle 1 are adjacent. Adjacent angles have no congruence or anything whatsoever. They just sit next to each other. That is it. Now I want to name a pair of vertical angles. Vertical angles they're angles that when two lines intersect, they are opposite of each other. And as we learn later on, they're going to be, with the vertical angle congruence theorem, we learn they're also congruent. Okay, so vertical angles, though, you have to have two lines intersecting. So up here, do I have a pair of vertical angles? Actually, I do. I have this line here that's intersecting this line here. So angle 1 and angle 5 are vertical angles. Nobody else, because nobody else has lines that are straight that intersecting, would become a vertical angle. No one else would have a line that would become a vertical angle. Okay, on number 9, we're going to determine if the statement's true or false based upon the picture. These are our postulates we were talking about. Remember all the postulates. Postulate 5 that said through any 2 points there exists exactly one line. Postulate 6 that said a line contains at least 2 points. Postulate 7 that said if 2 lines intersect, then their intersection is exactly a point. Postulate 8, through any 3 non-collinear points exists exactly one plane. Postulate 9, a plane consists of 3 non-collinear points. Postulate 10, if 2 points in a plane, their 2 points lie in a plane, then the line containing them lies in the plane. And postulate 11, if 2 planes intersect, then their intersection is a line. So we're going to use those postulates to determine whether these are true or false. Well, maybe not these exactly, but we're going to use them anyway. All right, so it says the measure of angle 1 is 47 degrees. What's the measure of angle 2? All right, well, this is a different postulate. Then the measure of angle 2 is 43 degrees. Sorry. If it's a straight line right here, then how many degrees are across a straight line? 180. So here, for these two to be true, that means that 47 and 43 has to be 180 together. That's 90. They're only 90 degrees, so therefore this answer is false. Okay, it says the measure of angle 1 is 47. Then the measure of angle 3 is 47. Well, 1 and 3 are vertical angles. So therefore, that is true because vertical angles are congruent by the vertical angle congruence theorem. That is a theorem. It is not the definition of vertical angles. Don't be confused because in proofs that might get you. All right, it says the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 4. Well, although we know vertical angles are congruent, if I just put some measurements in here, I could prove that this is not true. If we said that this is 40 degrees, then I know that here has to be what? Now my brain went dead, sorry. Has to be 140 degrees. I don't know why my brain went dead. So then this vertical angle for angle 3 would be 40, and this vertical angle would be then 140. So here, the measure of angle 1 and the measure of angle 3, because as for my picture, looks like this, that becomes 40 plus 40, which is only 80 degrees. The measure of angle 2 is 140. The measure of angle 4 is 140. Wow, that's 280 degrees. They are not equal. That statement is false. Let's go back and circle these guys right here too so we can see them. And then number 4 says the measure of angle 1 plus the measure of angle 4 equals the measure of angle 2 plus the measure of angle 3. Well, measure of angle 1 and angle 4 cause a straight line. So when it causes a straight line, I know I have 180 degrees there. Angle 2 and angle 3 make a straight line, so therefore I know I've got 180 degrees there. So that is true because both of them form straight lines. And I listed all those postulates because I thought this was that picture with all the postulates, but it's not. But that's okay. Postulate review is always good. All right. Our friend, Mr. Proof. Okay, so with our friend, Mr. Proof, number 1 says, given that, and this is a funny angle sign, it's how it imports it from the workbook into a worksheet, so I apologize, that is just an angle symbol. So it says angle 1 and angle 2 are complementary. That means I know they're 90 degrees. Angle 1 and angle 3 are congruent, and angle 2 and angle 4 are congruent. So I'm going to put that information in my picture so I can keep straight what I'm trying to do. I know that this is 90 degrees. I know that angle 1 is congruent to angle 3, and I know that angle 2 is congruent to angle 4. You don't have to mark up your picture, but personally I find it for me to be helpful because I'm very visual. I need to see what's going on. All right, so number 1 in my proof says angle 1 and angle 2 are complementary. Automatically, there should be no whatever. That's our given. It's given up here. It's given here. Now, because they're complementary, it immediately says the measure of angle 1 plus the measure of angle 2 is 90 degrees. If you recall, that's what the definition of complementary means. The definition of complementary changes it from words to numbers. And again, if it went from numbers to words, same thing. Okay, angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. That's right up there in my given. Oh, it changed it to be a measure of angle 1 is equal. We went from congruence to equality. Oh, you're right. That's the definition of congruent. In this case, it's angles. Definition of congruence always takes it from the congruence to the angle or from the angle to the congruence. Also, definition of congruent segments, just as a little sidebar, takes it from a congruent segment to a measurement, which is a distance of equality, then from an equality back to congruence. So that's what our definition of congruence does. It flips between the two. All right, on number 5, it says the measure of angle 3 plus the measure of angle 2 is 90 degrees. Okay, what did we do? We had up here about the same thing. We had 1 and 2 is 90. Now we have 3 and 2 is 90. Oh, right here, we remembered those two are equal. So what did we do? We just substituted in 3 for 1. So it's the substitution property. Whenever you're substituting into an equation, it's substitution. Now I have 3 plus 4 is 90. Oh, up here, we know that back to the statement number 2, we know that we have angle 2. Well, angle 2 is right here, but we also know that 2 and 4 match, so all I did was substitute again angle 4 for angle 2. And now I went from those two equaling 90 to stating they are complementary. That's the backwards of the definition of complementary. This is exactly what I was trying to prove up here. So now I know that 3 and 4 are complementary is what I was trying to prove. I know my proof is now complete. On your test, you will have a proof that is fill in the blank. We're doing baby steps. That's why we're doing them in class that way. Eventually we'll write our own proofs, but not until Unit 3, midway through Unit 3. Some little ones you did in your homework, but that's different. On your test right now, it's still going to be a fill in the blank. There's my postulates I was talking about. Here's the postulates I was talking about. All right, I just said them early. So, as I mentioned, for postulate number 5, postulate 5 states through any 2 points, there exists exactly one line. That just means I put 2 points, I can now create a line. Postulate 6 basically is the same thing, but now it's saying if I have a line, it consists of the minimum of 2 points. Has more, but 2 points had to create it. Oh, a line consists of, it's at least 2 points. At least 2 points. Okay, postulate 7. If 2 lines intersect, then their intersection is exactly a point. Postulate 8. Through any 3 non-collinear, means not in a line, points exists exactly one plane. Postulate 9. A plane consists of 3 non-collinear points. That means if I have a plane, I have 3 non-collinear points. Postulate 10. If 2 points lie in the same plane, then the line containing them lies in the plane. Sorry, lies in the plane. And then postulate 11, if 2 planes intersect, their intersection is a line. Oops, sorry. Now, what are we going to do with all these guys? Just like on your last quiz, there might be a picture and you're going to answer true, false statements about it. There could also be a question, which one of these is not a postulate? Which one of these is a postulate? As a multiple choice type question, that's where you're kind of going with these postulates. Okay, that's where we're kind of going with these postulates. Give you a second to finish writing those down. Or actually, you could pause the video. One or the other. Okay, it says to draw, the last but not least, to draw a Venn diagram that represents all squares are rectangles. If all squares are rectangles, then that means the squares are submerged inside of the rectangles, because all of them. So if I have a grouping of rectangles, then squares has to be completely submerged inside for all of them to be rectangles. Okay, questions on that? Guess not, it's a video. All right, so what are a few things that we just need to make sure we're correct on? A few things that we need to make sure that we understand is, one, when are we going to use the transitive property versus substitution? Because this has come up in class. These are kind of similar, but they're very different. The transitive property says, if I have A equaling B and B equals C, then A equals C. It transfers the knowledge. Substitution means you're submerging into another piece. So the way I kind of remember it is, because this is like a submerging, because you're substituting a piece, this is typically an equation. If I have an equation, I'm substituting into it. That's how I kind of remember it. If I've got angle 2 plus angle 3 equals 180, and then I have the measure of angle 2, that would be measure, sorry. The measure of angle 2 equals the measure of angle 5, then this is going to be substituted in to that equation. For the transitive property, it looks more like if the measure of angle 1 equals 90 degrees and the measure of angle 2 equals 90 degrees, they're both equaling the same thing, so now the measure of angle 1 equals the measure of angle 2. If A equals B, B equals C, then these two can go together. It's just worded backwards. So think of it kind of like that. The second bit of information is the definition of congruence. That's the biggest thing in any proof that's a problem. The definition of congruence takes a measurement that is of equality and then takes it and puts it into congruence with segments. Do the same thing with angles. If I have angle 1 is congruent to angle 2, now their measures can be equal. You see this in proofs. You see this in proofs. I think those are the two big ones that's kind of got people at the moment. Oh, and complementary and supplementary. That was the other one. The definition, I'm just going to do complementary. Means I'd have something that stated angle 1 and angle 2 are complementary. I know I'm writing messy, sorry. The definition states that now their measures, that's the definition of complementary, says that now their measures are 90 degrees. So that definition can take it from a measure to words, or from the words to the measure. It's kind of like that definition of congruence going back and forth. Of course, if you come up with any other questions, we're reviewing in class, so definitely ask them. This is just the highlights of different things we need to be aware of. Have a great day, and talk to you soon.